All right. You should be able to hear me now, hopefully. I'm still just getting the whole thing set up here. Twitter. I need to set up my Handmade network Twitch link. For now, I'll just post it again. All right. Let's see. Where did I leave off? All right, so I think I'm going to start by just getting a few changes into the way it appears and the ability to animate it a little bit. Let me look at my to-do list here. Because although I could do the audio processing first, I'm going to need some way to see the audio processing, and I don't have a whole lot of like built-in tools for looking at the results of that yet. So if I build the visual effect first, I'll at least be able to test and see that the visual effect looks right, and then I can tie that into the audio processing to actually give me a way of visualizing that the audio processing is giving me reasonable results, right? So I'm going to ignore the audio processing issue for a bit and work on the avatar thing. So down here where I say draw avatar, right now I'm sending down a center, a texture, and a window. I'm going to start making changes here. So first things first, I want to make them circles. So I'm going to grab a radius here. Let's see. I guess I want to pick like a number of points to go around the circle. So let's just start with something random, right? So then the number of vertices I need is I'm going to have one triangle for each of these. So there's my new verts array. And I'm going to walk that like this, because each one of those is going to go I plus 0 is going to start at the center. Hey, Andrew Harder, welcome back. I don't know about the UV stuff. I haven't actually figured out what I'm going to do with that. So let's just focus on... Let's just focus on getting the shape correct, and then I'll come back through and get the UVs correct. Although the center will want to look like that, right? So the first vertex of each triangle is like this. The second vertex of each triangle will be... Yeah, we need like center plus... I think over here in base math, maybe, do I have... No. Is it in base types? Do I have polar? Yeah, I have a polar thing. So I can make a polar, I can use polar coordinates to make a vector. So my theta is going to be I times tau f32. My radius is sitting right there. Again, same UV for now, fixing that later. And then this is the same thing again, except I'm going to add one more to I. So I'm doing a little bit more trig than I need to be doing. I'm doing twice as much trig as I need to be doing. I could figure out all of the points around the edge of the circle. And then use each one of them twice to fill this out, but I'm just going to do the trig twice because it makes it easier to write this for now. Optimization passes later. So that can be done. And that makes this 3 times circle approx n. So let's see. No, didn't work. I need to plus 3 here because I'm going by 3 at a time, but I don't. Okay, so I need to do. I should probably just use like a proper iterator. Yep, BYP, you caught it. That didn't do everything either. Let me just remove a couple of possible sources of confusion here. Let's just put in the good old test color to make sure that the UV guessing isn't the problem. Okay. Reverts. Okay. Hey there, keeping track of this account. I'm sure it has been a long time, but I don't think I know who you are. It looks like you might have changed the name on your account. I'm not sure. Triangle, triangle, triangle. That. The radius. Tau. Oh wait, this is wrong. It's not times tau. I need to be doing right. F32 I. Yeah, I need like a theta denominator, right? And that needs to be like the reciprocal of this thing, or like theta delta, something like that. Actually, even better would be like, why don't I just bake that into there? I need to switch over to turns, but I haven't done that yet in this code base. Oh, wow. So yeah, that was back in 2019 when Casey and I did some streams together to work on Vocoder. Okay. So we have a circle approximation, and yeah, I haven't seen Casey since the pandemic. I think he has become more of a hermit. But you know, he does stuff online. He does stuff online and stuff. You can still follow what he's up to. So let's see. That's pretty circly, right? I could be convinced that I'm looking at a circle there. So now let's talk about the UV coordinates. I mean, really the smart thing I would do here is I would have like a table that's like yeah, I'm not going to worry about optimizing it. There's a way to do this that would be very easy, and then if you could pre-bake it in the compilation pass, it'd be even better, but you can't because of C stuff. But we can get the UV thing more right. I'll call these W1 and W2. These are just going to be polars with a radius of 1. And this is radius times W1 and radius times W2. Now, the issue I'm going to have here is it'd be kind of like this, right? I think, except it might be that I need to flip the Y because in UV coordinates, 0 is the top of my texture, but in OpenGL coordinates, 0 is the bottom of the screen. So I think this is going to end up upside down. It might also be pink. Yeah. So now we need a solution to that upside downiness. So that would just be like this, right? We're just gonna flip these so that that can go there and that can go there. Boom. Okay, so now we got that. It's all like pixely on the edges. Now we could do some like multi-sample anti-aliasing to make that look better. But I'm not gonna do that yet, because this isn't the end of what I want to do anyways. I also want to add in like a sort of gradient on those edges there. I've got some ideas about how I want this to look. So let's take this another step further. So I've got, I need a minute to think now. I've got this like radial circle fill thing. But I really want two circles, so an inner one and an outer one. Did I have that misspelled all day yesterday and not notice? It's crazy what trying to program on stream will do to you. Yeah, BYP, I've been playing around with them and I've become disillusioned with SDFs. They're very easy to implement and that is cool. I like that. But I'm starting to get fed up with using them all the time. There's certain things I can't get to work with the SDF quite right. Like the anti-aliasing is just never, it's like 80% right. And I can't seem to make it any better than that. But yeah, that would have been me about 2 months ago too. I don't know about whatever that is. Green space deriv for AA. I don't know. Hey, Young Lane, young Lane, welcome back. All right, I want a thing that's like avatar inner radius ratio or something like that. Inside ratio. How about that? I'll set it at like 80%. All right, so this is gonna start getting weird. I might need to draw this. Uh-oh. Let's not look at the Mr. Fourth one today. Let's make one of these. Okay. Drawing. Okay. Here we go. So here's what's going to happen. I'm just drawing this out so that I understand the geometry, so I might not do a good job of explaining it, but I do want anyone who's watching who's curious to understand what I'm doing to go ahead and ask questions if it doesn't clear when I'm done with this, but kind of for my own head first. Got a radius with a circle like this, and I'm like dividing it up into wedges. I get all these triangles. Now what I want is like an interior, like this. So then that one's pi wedges, and then these, I need a pair of triangles that goes like da, 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 da. Right, and that would go like that. Okay, so what I want is 2 rings of circles. They're going to have the same number of subdivisions, and then I'm going to triangulate, so the pie-shaped thing in the middle, but then on the outer ring, it'll be like quads, essentially, that are like trapezoidal. So I'm going to grab, those 4 points and make a quad. So the number of total vertices I need, the number of total triangles I need, is however many slices I have times 3, right? This, like if I have an n degree approximation of a circle, then there are 3 triangles in each slice. And the reason I'm doing it this way is so that I will be able to leave these mostly in place and then wiggle these outside ones around, add effects around the radius and stuff like that. So 3 times the approximation degree. Okay. All right, I'm going to start getting a little more serious about laying out this loop. So vertex V is going to start with verts, and then every time I'm going to go for each approximation of the circle, I'm going to add to the V pointer however many, or this is verts per approx, right? Verts per approx. So that way V is incrementing by the right amount. This here is the same, but this, I'm going to grab a VV, which is going to be, wait, I don't need to do that. I just need to go V, and I can get rid of these I parts, right? So it's V0, Boom. Whoops. Okay. So that gives me inner triangle, outer triangle 1 will go V3P equals center plus radius. Oh, I need to pick 1, 2, 3, 4, 5 points first. Let's grab those 5 points. V2F32. The center I don't need to grab. But the 4 approximation points are going to be P1 in is like, okay, P1 inner, P1 outer, right? So P1 outer is the one we already had. P1 inner is that's, oh wait, that's the UV. I want the P1 inner and outer to be based on this, but the inner is just that times the ratio, right? So I shrink it in by that much. And then P1, P2 inner and outer is just W2 like that. And then I also need UV1 and 2 inner and outer. Okay, this will make it easier to set up the vertices if I grab the points I want first. So this is the center of the UV space times the radius of the UV space with the flipped W vectors. And then I do center, 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 1. Okay, this right here is P1 inner, UV1 inner. Why don't we do this? Why don't we come up here, just pull this out. UV center equals here's our UV center. Cool. And then this is P2 inner, UV2 inner. Okay, there's the inner triangle. Outer triangle 1 is going to go from P1 inner, UV1, let's just do this. P1 inner, UV1 inner. To P1 outer, UV1 outer, and then P2 inner, UV2 inner, okay? And then outer triangle 2 is gonna go, let's see, we need 6, 7, 8, 6, 7, 8. 6, 7, 8. Okay, this one's gonna go from P1. I did that thing again. I should just take this one. It's a freebie. 6, 7, 8. 8. 8. P2 outer, UV2 outer. vert per approx. Vert per approx, circle approx n. Okay, so it doesn't look any different because I'm still triangulating the entire same area, same UV, mappings happening. So it doesn't look like I changed anything yet. But now I can do some experiments. For instance, we can say, what happens if the alpha goes to 0? Just as my first idea. I don't know if that's the effect I want. I just want to start seeing it work. Okay. That's not quite right. I want the inners to continue to have an alpha of 1 and the outers to have an alpha of 0. Okay, so there we go. I don't like that effect, but that's like what we can do now, right? We can make stuff happen. So I do have to point out a couple of weird things that I'm seeing right away. It seems like it like cuts off. You see what I'm saying? Like, it seems like there's a band there. I wonder why it seems like that. Like, why does it have a hard edge? Rizoma, yes. It's, you're not that late. We kind of just got started, and yes, I am mapping a disk onto the avatars here. The ultimate goal, as Andrew put it, is to use some of the outside edge of the avatar to create some of the audio visualization effects. And I might also I have some other ideas. We'll see how far we can actually take this. But for now, why does it seem wrong is the question. Why does it seem wrong? Alpha blending is on. Like here, there's another separate issue, which it looks like it's getting clamped, but that isn't actually happening, I don't think. That's just the way the avatar actually looks. But it definitely looks like the alpha snaps, right? Like, I don't know. It doesn't feel like it goes to 0. There could be a number of things causing this, but like here it suddenly starts blending a lot more black all at once, right? Let me simplify the problem for a sec by switching back to our good old handy magenta. Maybe it's just right, and I don't know. It's hard to call. It's a hard call to make. Maybe it's just that the band here is so short. Could also be that I need what if I do a couple other experiments real quick? GL clear color. Make the background pink, make the shape black. So that just looks right. So maybe the alpha isn't the issue. Maybe the band is too short. Yeah, it very well might be that by linearly interpolating, I might want to figure out a different way to choose my alpha value for this effect. I mean, it's a circle. I could be doing all kinds of simpler things. But like, let's say I push it all the way into like halfway. I feel like that's more like what I would expect. I mean, if there's a band, it's like here, but I think that's just right. Maybe it's a little bit too strong, though. It's so weird how you can see it like immediately, but I don't know. It might just be that that's an optical illusion. I'm not sure. It could also be like I might need to do sRGB stuff real quick. Let's try that. Yeah, Andrew, it does feel like there's something weird happening when it's the colored texture thing. The texture itself is just RGB. I want to try switching on gamma correction. Um, Here we grab the raw text, the raw buffer. We resize it now. I think there was... I need to figure out the following functions interpret image data as gamma corrected sRGB. I hate it when people like put the name sRGB on things, but you don't know, does this mean, so it's like resize sRGB mean that it takes, does it mean that it's something that has been converted into linear space or out of linear space, right? Is this the one that runs on things that are already linear? And if so, I need to run the sRGB correction myself first. I'm not sure. In all likelihood, this is not in linear space when I load the file in. So I would need to convert it to linear before I could do anything with it. Unless... Okay, I think this must mean it takes in an sRGB and outputs an sRGB. Let's try resize uint8 sRGB. Input width, input height. Set this flag if your texture has pre-multiplied alpha. Otherwise, STBIR will use alpha-weighted resampling. Effectively pre-multiplying, resampling, and then unpre-multiplying. No, it's not pre-multiplied. The following functions interpret image data as gamma-corrected sRGB. Specify STBIR alpha channel if you have no alpha channel. No alpha channel. Okay, so width, height, input strident byte 0, width, height, inputs, output strident bytes 0. Number of channels, 3. Alpha channel none, flags. The specified alpha channel should be handled as gamma corrected value even when doing sRGB. I don't know what that means. I don't have an alpha channel. So that will just change how the resize works. I won't do anything else. Second, I'm uploading the texture here. This is where I need to remember some OpenGL stuff that I haven't done in a long time. But I do have this sRGB. What does it have? sRGB. Okay, I'm gonna have to look at docs, I think, for this. So, GL text image 2D. Let's take a look. Is GL sRGB one of the options here? Yeah, it is. Internal format may also be one of the size internal formats. Okay, so internal format is this one. sRGB 8. If the internal format parameter is one of these sRGB things, the texture is treated as if the red, green, or blue components are encoded in the sRGB color space. Any alpha component is left unchanged. The conversion from the sRGB encoded component to linear component is, as such, assume is the sRGB component in the range 0 to 1. Texture 2D, proxy, texture 1D array. Try to high resolution and format the implementation. It's best match with the requested storage resolution to query this state. No. Okay. So I think what I need to do is set this to be using an sRGB texture, but I think there's more to it than that. Right? Let me just see what happens if I search this. Boom, boom. Take a look at both of these. Normally, color values in images are assumed to be in a linear color space. However, it is often useful to provide color values in a non-linear color space. OpenGL provides support for the sRGB color space. These are the two normalized integer formats. What this means is that the values placed in images of this format are assumed to be stored in sRGB color space. When fetching from sRGB images in shaders, either through samplers or images, the values retrieved are converted from sRGB into linear. Okay, thus the shader only sees linear values. Note that the alpha value, when present, is always considered linear. Colors accessed from textures via GLSL samplers undergo filtering based on sampler properties. However, filtering is a linear process, while sRGB color space is a non-linear color space. So filtering in the sRGB color space does not result in reasonable values. However, OpenGL implementations are allowed to decide on their own whether filtering happens before or after color space conversion. The difference, while certainly present, is usually not that great. After the color. Gotcha. When images with this format are used as a render target, OpenGL will automatically convert the output colors from linear to the sRGB color space if and only if GL frame buffer sRGB is enabled. The alpha will be written as given. Okay, so what I have to do first is make an sRGB8 texture, and that's going to change the way it looks dramatically. Let's grab these and plop them down over here. that should just, yeah. So now it just looks wrong because it's using linear color space. And I think the banding looks maybe like it's removed. At least I can't see it very clearly here, but maybe it looks like it's still here over there. But either way, if I'm going to do sRGB, it's going to make all of the color blending correct, but then I have to convert back out on the way out because the screen is still actually gamma corrected, right? And so when you don't apply any correction and you don't do any blending, it's right. Once you start blending, you want to convert into linear, blend, and convert back out, and I haven't done the convert back out part. So to do convert back out, I need a frame buffer. That's the easy way to do it. And I don't know if I have any frame buffer stuff sitting around. I might have some frame buffer stuff sitting around in my example over here. Yeah, it looks like I do. So let's copy some of this in. We're going to grab a new frame, set up a frame buffer in our OpenGL setup. Texture. Okay. Set up an sRGB texture. One sRGB canvas texture. GL bind texture. GL texture 2D. sRGB canvas texture. GL text image 2D. Yeah, like this. We want sRGB 8. We want the width and height. I'm just gonna do what I did over here. 2048, 1920 by 1080. Yeah, that's big enough. And we got zeros here. So that should give me a blank texture to work with. Let's catch errors. sRGB canvas texture. Failed to set up sRGB canvas texture. How's that look? It works. Okay. Next, we need the actual frame buffer. This sRGB frame buffer. GL bind frame buffer. GL frame buffer. sRGB frame buffer. GL frame buffer texture. GL frame buffer color attachment 0. sRGB canvas texture. Frame buffer status. And if sRGB frame buffer, that would be really wrong if that was here. I'm not sure why I'm testing that, but failed to set up sRGB frame buffer. So in theory, I should be able to render to that frame buffer. And since it's got a sRGB texture attached, it would do the conversion out. At frame buffer sRGB needs to be enabled. Enable conversion from linear to sRGB in rendering. GL frame buffer sRGB. OpenGL definitions. There we go. Okay, we're making progress. Now I need to render to the frame buffer. In order to do that, what I want to do is before anything else, I'm going to bind my sRGB frame buffer. sRGB frame buffer, and then it can do all that stuff. And then after that, it can resolve sRGB frame buffer onto window. It's gonna look like this. sRGB frame buffer is my read, 0 is my draw buffer, window dim S32 is correct, color buffer bit GL nearest, and then bind to 0 to finish things off. Okay, so now it's back to the right amount of color, and I don't see the band. I don't know if I'm crazy, but does anyone see the band? I feel like the band is gone. I'm also not seeing like man, that fall off is a lot softer now. I mean, there's definitely some amount of alpha blending towards the edge there, but it's dramatically less, it feels like. Let me just play with that real quick. A equals 0.f. It feels like if I do this, I will see the pixely circle again, right? Right, so there's full-on pixely circle. And then I say, okay, go ahead and fall off to an alpha of 0. And it's like, it's just barely any fall off there. I mean, maybe that's good. I don't know. Maybe that's what I want. I also feel like I could go for a little bit more, what's the word? A little bit more precision here. So let's bump this up to 96. Yeah, I think that was it. I think that switching to sRGB did in fact fix the All right, Rizoma, thanks for coming and hanging out. Have a good one. I think the sRGB thing fixed the bad band that we were seeing before, and the fall off now is like too gradual when it's linear. But that's okay, because what we can do is actually just correct the easy way to correct that, or to it's not really incorrect. The easy way to get the effect that we want to see, or that I want to see, is to take this A here and modify it a little bit. So it's going to be linearly interpolated between 0 and 1 from the inside to the edge, 1 down to 0. And what I want to do is I want to modify it in such a way that it tapers off a little bit faster. So we could try like squaring it, for instance. That would make it a lot faster, but let's just see what that looks like. So that kind of is sharp enough that it brings back the bands. Now what I wonder is could I do something like smooth step. I forget the order of arguments to smooth step. Edge 0, edge 1, X. So it's really just putting like the cubic on the already existing range of 0 to 1 is what I want. I feel like that's about right. the band's a little bit back, right? This thing. I don't know. So another option I have is maybe what I do is I just sort of shift it. So 1 will remain 1. Yeah, maybe I want to... Let's linearly interpolate from about -2, -0.2 to 1 minus -0.2, -0.2 to 1 minus -0.2. I'll clean up the goofiness of the math there in a minute, times FA, right? So there, if that's a 0, I get -0.2. If that's a 1, I get 1. And then what if I clamp that? No, I don't like that at all. I'm clearly doing something wrong. When F is... Is it order of arguments? There we go. I think that's more like it. I'm not sure, though. I'm not sure. That might just be a silly, like... I mean, what's the point of doing that when I could just like shrink the circle? Is that really better? That's the only question in my head. Yeah, it's not really different by much. Maybe then, if that's true, then maybe the only issue here is that this thing that we tuned earlier when we didn't have the sRGB is wrong now. Maybe I can go back to like 0.8 and get the... Yeah, that's more like it, right? That's more like it. Maybe a little softer, but that's kind of what I want. Okay, so I don't think there's much else to do there, but I want to do some other tricks. So right now, why don't we grab... there's one more thing I definitely want here, and that's going to be... Can I get GLSL? I just want someone out there. Do you have a GLSL HSV RGB convert? What have you got? HSV to RGB. Let's try it out. Loop, loop, loop. Okay. So this is our HSV. I'm just rearranging things to make it the way I'm used to reading it. Multiplication and division don't have spaces between them. Addition and subtraction do. This is so compact, but if this is right, then this is what I want. HSV to RGB. I'm also going to need an RGB to HSV. Kind of thought that they would come together. Really, this should be RGB from HSV. This is... This is not GLSL. Can I get GLSL RGB to HSV? Here we go. This is both of them. So yeah, there's that one, and here's this one. Well, HSV from RGB. Man, it'd be nice to have, actually, no, I can't because I have to sample the colors first. Yep. Oh well. That name is fine. -1/3, 2/3, -1. Okay. So I think what I want to do here is go, I've got a color in linear space in RGB form. Let me get this in HSV form real quick. HSV from RGB, text color. And then let me modify that. So HSV modified will be vec3 HSV, same hue. Let's make 0 saturation, same value, right? And then RGB is RGB from HSV. Here is the modified HSV. RGB. Line 9. One, 2, 3, 4, 5, 6, 7, 8, 9. This will be it right here. P, here it is, HSV. Line 24. 10, 11, 12, 13, 14, 15, 16, 17, 18. Right there it is. That's what it looks like when I drop the value completely. Or the saturation completely. HSV.y. So there's if I run the conversion. Here's if I don't run the conversion. It looks like it's converting in and out correctly, but for some reason it's super bright if I drop the saturation to 0. Really? It's just brighter than I expected, I guess. Man. It seems surprising, doesn't it? Yeah, I mean, it kind of looks like it's doing what I would want. It's just not quite moving things around in the space the way I thought it would. Maybe my avatar is brighter than I realized. But yeah, I can like sort of desaturate things, and then I can probably make them darker too, right? Nice. Okay. So what happens if I make them like that? Then let's keep just dropping that down, like we'll make it real dark. Wow. Okay. But now, what I actually want to do isn't quite that yet, right? So we've got that piece in there. I think that's going to be useful. But the next thing I want to do is oops, sorry. Let's see. HSV RGB is done. What else have I got going on? So that's more detailed geometry for the avatar. So I want to have parameters. For highlighting avatars. Okay, so what I've got is I have a couple options for how I can highlight one avatar over another, right? So I've got this draw avatar call, and I'm filling out all this geometry. Some things I could do is like optimize that, but that's not an issue yet. But I can affect parameters on these vertices in different ways. And I can also affect the radius that I am using on these. So I want to be able to, let's make a block of a couple parameters here on how I can draw one of these to pass down. So radius, I think these 5 parameters will define what I want to be able to control for now. I might add more. but that gives me a center, a texture. Yeah. Throw the parameters block right there. Params radius. Now let's see the inner triangle. We'll have, yeah, now we can have saturation inner and value inner dropped in right there. And alpha, yeah, okay, so what I'm gonna do, I'm gonna make a list of these, so these can go away. This lays out the geometry of the triangles, like the layout on screen and the UV coordinates, and then I'm gonna have an inner and outer parameters right here. And in order to handle that, I'm gonna have inner index are 0, 1, 2, 3, 5, and 7. And the outer indexes are 4, 6, and 8. Inner index v inner index j dot a equals 1 v inner index j dot s equals params inner sat inner, and v is val inner, and then another loop over the outer indexes to give us a 0 sat outer val outer. And then when we draw avatars, let's just start with a parameter block for now. Avatar params, and fill it out like this. Radius equals avatar display radius. Params dot saturation inner can be 1. Saturation outer, make that 0. Val inner, can make that 1. Val outer, we can make that 0. We might just drop the alpha thing if we have the value going to 0 and the alpha going to 0 at the same time. Let's do this for now. Okay, here's the params. Same for all the avatars for now, but all I've done is modify the geometry. I haven't actually sent any of it to the vertex shader. So let's go to draw avatar again and say, now we want to modify draw geometry. So these are going to take a 3 for S and a 4 for V now. So just like we can modulate the alpha, we want to be able to modulate a multiplier on the saturation and value. Okay, and then this becomes F saturation and F value. Not quite right, but getting there. So what is happening here? Is it just dropping saturation to 0 automatically, or is that like the saturation fall off curve right, like right here, you can see that it's not going straight to gray. There's like some blue still in the band and some yellow still in the band. And I think it's less obvious here, but you can kind of see that it's very barely still blue here. So I think that I'm having a problem with this particular color space where a linear fall off on the saturation does not give me the effect I would want. Let's play with a few things. So A equals 0.f. Let's just say you are going to do that. And what if instead of using alpha to make it darker towards the edge, we used value? That doesn't make it any better. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Yep, that should work. V, that's that. Saturation. I mean, it does appear to be mapping the parameters the way I would want to the vertices I would want. So I think it's just a matter of the saturation fall off is too sharp this way, right? So I'm taking the original saturation from the color, modulating it from 0 to 1 linearly, and the fall off is way too fast. That's worse. Or is that worse? Or is it just that I eliminated the thing that does that? Okay. Let's just focus on the saturation piece for a second. So when the saturation falls off like a square root, it looks like that. When it falls off linearly, it looks like that. That is more like what I would want. It's crazy that it takes that much to get it there. Yeah. I feel like there must be something wrong with one of these. I'm gonna take a quick break from fiddling with that and just double check. Because it just seems so bright. Like that just seems so bright. Doesn't it? Doesn't it seem bright? Like why is it white? Surely it should be a little bit less white than that. It seems like it's getting brighter when I drop the saturation than it should. So maybe I want to take a quick look around for another converter. Let's try this guy's converters. They're much more verbose, but maybe they're better. I don't know. Well, that's not right. Okay, rolling those out. Next. Nope, that's not GLSL. This is the one I already tried. HSV to RGB, algorithm to convert RGB to HSV. Color designer, convert X, color concentration, hue, and GLSL. Vertex, RGB to HSV to RGB for shaders. Let's try this one. Ooh, these look maybe good. I mean, this looks like the same thing that I already copied. Could be a typo in there somewhere. I don't think there is, but it looks like this is like the same code. Yeah, it's like exactly the same code. And this one. Yeah, I guess that's just okay. So that's not gonna help. This was fine. It's not an issue with the HSV RGB conversion. It's just that it's brighter than I expected it to be. Okay, so we do that, and we get something that's sort of, whoops, S-mod, please. Yeah, that's a lot more like it. Okay, I'll go with that. So it's falling off into gray there, but it's super bright. So then what we do is we say, hey, you should also get darker. That's kind of better. I kind of want it to get darker faster. So let's say that there's like a V modulation as well. And the V modulation is determined by something like this, maybe? Yeah, okay. Okay, I think that's sort of the right idea. Okay, so that'll be what it looks like. Well, is that too much? Yeah. Maybe it would actually be better to go that way. That starts to lose the very important alpha falling off. But you know, I'm gonna leave this one like this. I'm gonna go back to using alpha for this, so that I just have that in place. That's blending with black. just occurred to me that maybe what I need to change is that ratio thing. Yeah, that should be... That should be a parameter. And when you're talking, it might look like that, except that the inside ratio should be like smaller, maybe. Yeah, I think that's maybe more like what I would want. Not sure. Hey there, Bon. My keyboard is this one? This is my keyboard. Unless you mean this, in which case this is my keyboard. This is the piano keyboard. I don't really know how to answer your question. It's a Casio, I guess. I can't see the label on it from here, but I'm pretty sure. It's like an extremely old one that I just use for noodling around. This is a code keyboard, which I use for programming. Yeah, the only issue here is that like that band's way too hard, right? Like if I had that like that, that's pretty good. Right, if I have alpha and value at the same time, it kind of creates problems. So I think I want to stick to alpha. It's still funny how much it looks like there's something wrong with the UVs on the outside edge, but there isn't really, is there? I don't know. What else might I do to emphasize it? Well, anyway, so that's what it looks like when you're talking. And then let's say you're not talking, then I think what would happen is I drop this down like this. And I drop these down like this maybe. And I drop this like this. Maybe I do more like this and this. Yeah, cool. Okay. So that kind of gives me the idea of what I want it to look like. So I have the ability to modulate these avatars a little bit to show some results from analyzing audio. So let's focus on getting a little bit of audio analysis flowing through so that I can have each avatar changing in accordance with the audio analysis. Andrew, where did you see the hard cutoff? I was trying to look for that. Like right here, does it look like a hard cutoff? Is this the one you're talking about? Because I do kind of see that it looks like that, but okay. Here's the thing. I don't know if anything's going to make it not look like that. Like, oh man, it's... What am I doing that isn't what I expect? I'm not sure. Like, okay. If you want to... Yeah, so if I were to take this out, right, and have none of this saturation stuff, how does that look to you? Does that look banded as you're saying? what is actually happening on the right there? That looks... I mean, one thing that might be... Yeah, what is going on? So one thing that might be happening is I made this a lot tighter. So make it soft again, like gradual. You see an issue here? You can still see the outer edge in this one. Okay, this one's better. So this is with nothing but an alpha fall off and a nice soft alpha fall off. The edge isn't supposed to look blurred necessarily, but it is just going off to, I mean, maybe blurring would be a better effect than what I'm doing. Maybe I want to have like a blur that gets stronger towards the edge. I'm not sure. I'm not sure what the intent of your question is. This is another issue that's going to happen here is I have weak aesthetic preferences. So you can show me something and I'll be like, oh, that's a cool effect. And then everyone else will be like, that looks all screwed up. And I'm just like, but isn't the screwed up look kind of cool? So I am kind of relying on other folks to like tell me what is clearly a bad effect here. So when it's, I can see the difference, like I can clearly see the difference between doing that and that. In the sense that here it is distinguishable that something funny is happening on the edge. But I'm not sure that I think it's a bad thing. But I could see why someone might think it's a bad thing. Here, I can't distinguish an edge. Like, I don't know where exactly it starts. But I do see that, like, by the edge, it looks kind of extra soft. But that's more or less what I'm going for. It might also be that I want to apply different effects at different radiuses. Maybe a part of the problem here is that, like, the alpha fall off should look like this. And then my other things, I don't know. I might also not want to have saturation changing as a parameter across the image, but only over time. That might just be better to do. Like, I definitely want to have the ability to say, like, if this avatar is talking and this one is not, that it is shrunk down and desaturated. I think that will work. The question is, do I want to use that effect to make anything? And maybe this is just what I should stick with. I should stick with this as the look for an avatar that's talking. I think that looks good. I think that looks good. I mean, I'm still going to add in... You think it's not approaching zero smoothly? Like, you think this is not an alpha of zero here? Like, it's going, and then it's crashing from, like, something high to something zero, right? That's what you're saying? Because I agree it looks like that, but I don't know... I mean, that's what I would expect, right? What you're saying is what I would expect. I would expect to not see a circle here. And, like, or rather, not to not see a circle. I would expect that it looks like it goes the alpha should drop all the way to zero. And I do agree that it kind of just doesn't look like that's what's happening. So one thing I could do to test is let's drop the texture for a minute and just look at the parameter f of a. If that goes to black, yeah, it doesn't. Let's make the background good old-fashioned magenta. See, it does get to black. It's just it doesn't get there very much. It doesn't get there until the very edge, right? So there's this pixely circle, and that's disappearing. Open file. open full. Okay, so here's the screenshot. Let's edit that. No, that's not an editor. Give me PaintNet. Drop this onto PaintNet. Open. And like, here's the edge pixels here. And they're, you know, they're not all perfectly black. But they're, like, this one's perfectly black. This one's very close to it, right? So at the outer edge where it gets closest as it can get, it hits black. But there are definitely like a lot of pixels in the circle that are a little bit above black here. Like that, for instance. So a part of the issue might be like it's not including this pixel in the primitive, and when it like figures out how strong this pixel should be, it's pretty deep into the primitive already. So we get black on the absolute outer edges. Let me do a couple things. I have a couple ideas of what might make that look a little better. Let's just make sure that we don't get like much better results if we pop up the approximation to be better. Because it might be that with a higher quality approximation of a circle, we get like, you know, better primitive coverage of the edge there. Where's PaintNet? Open. Yeah, so like that's the same, right? That's the same. So it's not that. I think 96 is enough. I think it's more than enough. Lu Chong, are you interpolating before or after sRGB conversion? So yeah, let's take a look. sRGB, interpolating what, by the way? Am I interpolating which parameter? Because there's a lot of things that get interpolated. Am I interpolating which thing? But we could just say, let's turn off the sRGB thing and double check. So I can toggle that to toggle the conversion from linear back to gamma corrected. And I can say right here, if we are doing sRGB conversions, make, oh wait, no, not here. GPU texture from file path. Yes, right here. Internal format equals GL RGB. If we're doing conversions, then instead give me sRGB8 internal format. So here's with sRGB conversions enabled. Well, I don't know that this is actually going to make any difference. Here's with them disabled. Okay, so that if I disable sRGB gives you that faster darkening thing, right? Because when I'm blending now, I'm blending colors that are not getting converted back out to I'm blending colors and they're not being converted back out from linear to gamma corrected, right? So when you do that, you get darker results, which makes sense. Which this might be what your eye is expecting a linear fall off to look like. I'm not sure. Is this here? Enable. Where is our magenta now? So if I make my background black, the question is just from white to black, does that look like a smooth gradient? Because to me, it looks like it's very white and it immediately drops rapidly and then gradually goes to black from there, right? Which is the SR, like that's basically showing you what the curve looks like when it's done in sRGB space. Or rather, to put it another way, when my colors are being blended and not converted from linear to sRGB, so I'm essentially doing my pure color computations in a nonlinear space here. And then if I enable this, and I could be wrong here, I might be getting the conversion wrong on one side or the other, but if I enable this, now it doesn't fall off hard here, but it doesn't look like it went all the way to black here the way you're used to when you do your color fall offs in after sRGB conversion. I thought the whole point okay. So let me read what you're saying and think about it. Lu Chong says, I'm not sure about your parameters, but I think that to make linear interpolations actually look linear to our eyes, they need to happen after sRGB conversion. So I'm currently when I apply sRGB conversion, first I do all of my color computations, render them onto render them onto a texture, and then I do all of my color computations, and then at the very end, convert to sRGB, or convert from the linear color space back into sRGB. If I were to convert to sRGB first, sRGB is the nonlinear space, right? So this is what happens when I first go into linear space, do my computations, do all interpolations and stuff, and then at the end convert to sRGB. And this is what it happens if and since I don't have any input colors here except for white and black, it wouldn't, like, those don't need to be converted. They're correct. The white and black are the same in linear or nonlinear. It's just the intermediate grays that are different, right? So my input colors don't need to be converted in this test case, right? They're correct either way. But my output color here is whatever was in the linear color blend. Like, I do the blends and I don't have a linear to sRGB convert afterwards. So none of that matters though. Is this what looks correct or not? Okay. Now, if I go here and I say, give me the RGB, that's what it looks like. So here, whether I do conversions or not, this is going to look correct. And the reason for that is, to disable my conversions, sRGB images are coming in, they're getting put on the screen without any blending, and then they're coming to my eye. And since the screen interprets the pixels as sRGB to begin with, they are encoded in the nonlinear space, but then they come out in the nonlinear space too, which means that it's like as a match. It's a type match, right? There's no convert in or convert out, so it's just correct. And there's no blending happening, so there's no like technically wrong things. But I've turned off any of the fall off on the alpha here, so we just have the pixely circle. I just see star, star, star. What I was thinking about was, are you sending a link? Is Twitch like blocking links maybe? Okay, now if I enable the alpha fall off, it looks like this. How does that look to everybody? Because to me, it looks like there's like a line right here and a line right here. Over here, I'm not sure if I can see it as easily, but it's like a line right here. I can sort of see a spot where something changes. If you want to send me a link, Lu Chong, you could send it to me on Twitter or on Discord if you know how to find me on either of those, and I can check it out that way. If you try to send it to me in a direct message on Twitch, I'm probably not going to see it because I've never had success using direct messages on Twitch. Okay. So the issue here is once if I don't do any sRGB conversions, right? So we have the inner band is less noticeable here, which is true, but I can make it noticeable, right? So I'm hiding the inner band. Either way, I can kind of hide it by making this a softer number. If I put it closer to the edge, can you see it now? Because I can clearly see that the inside circle and the outside circle are like dramatically different all of a sudden. If I turn on the sRGB conversions, so I take the texture, I take the avatar, I assume it's an sRGB encoding, and I convert it into linear. I blend it with the background, which is black, in the linear color space. And then I take those blended results and I convert back to sRGB in order to display on the screen. And now I can't see a band here, but I do agree that the edge doesn't go towards black as fast as I would expect. But I think that that's right. Like, I think that the reason that this doesn't look like it's going all the way to 0 is because you're used to seeing people do all their calculations in the nonlinear space. Like that's sort of my guess on that. I could be wrong. It might be that I need to use a different curve still. But at the very least, this makes it look like there's no immediate change here. The linear space is linear in the sense that you want to do your color blends that way, but you still have to convert back out to sRGB so that the screen displays it correctly. I understand the whole thing about the eyes, but that's a little bit confusing. The reason people talk about the eyes is to explain why our screens are more sensitive, like why we even do any of this, right? The whole point is that there's more information at the dark end of the range than at the bright end. So the fact is that after the blending is done, I do go back to sRGB so that when it goes to the screen, it matches how the screen interprets the data and it sends out the colors. I think that this is the right way to do the sRGB. I'm pretty sure, but I don't think that the effect is exactly what I was hoping it to be. That's all I think is happening. And you definitely don't want to do your color interpolation and blending in sRGB space. That's not how that works. Because that does the math the wrong way. The point is you don't want to display stuff that's linear. But you don't want to blend stuff that's sRGB. I don't know. So some fixes could be, let's just try what happens if I'm like, look, fall off faster. Come on, fall off faster for me. I feel like that just doesn't actually do anything because it just kind of squeezes in the circle. It's like I'm basically shrinking the radius. So another option is that I don't want it to be quite linear, maybe. Like the alpha fall off there, maybe it shouldn't be quite linear. Maybe I should have A be like, after I've linearly interpolated the A parameter, maybe I want to put some kind of power curve on it. So let's just play with that for a second. So maybe to make it just a little bit faster, I can just like bump up the power a little bit. I don't know. Luchong, I'm happy to like talk about this, except my understanding of it is basically flipped from what you're saying, and I don't know if I want to spend all day going back and forth on it right now. I'll take a quick look at the link, but I don't think you want to linear perception. I feel like you're putting the pieces together the wrong way. Let's take a quick look at what you sent me. Right, so here's linear in the amount of energy and linear space perceptually. Okay. Right. Mm-hmm. So, okay, real world object looks like this. We have limited bits. Right. So this is linear. Is he claiming that this is linear in light scale? No. Okay, so this is perceptually linear, but the computer is displaying things using bit a correspondence between bit patterns and light intensities that is linear in the energy. And it's pointing out that in order to match this as closely as possible, there's a lot of extra information here and low amount of information here. So then what they're doing is they're switching to a nonlinear encoding so that they have just as much information available here as they do here. So it's both these are both approximations of this thing, which is perceptually linear, but this one, the encoding is sRGB, so that you have more information here compared to this one and less information here compared to this one. Gamma encoded values, yep. He warns, of course, that you're probably confused because, like everyone, he talked to you about how your eye works, but now he's going to talk to you about how the computer works to compensate and not explain the basics of how you actually apply any of this up front, which would be the right thing to do first, I think. Right. Okay, so the ultimate goal of gamma encoding is to put the image on a computer screen and then let a human view it. Right, so here's the curves. Yep. Okay, so if the whole world defaults to sRGB, what is the problem? If our cameras write sRGB JPEGs, we can just decode at JPEG data, copy it to the frame buffer, and then it goes to the sRGB monitor, and that's correct. The problem will happen in the moment we start running any image processing algorithms on our sRGB pixel buffer directly. Remember, gamma encoding is a non-linear transformation, and sRGB encoding is basically just a funky way of doing gamma encoding of around gamma equals 1 over 2.2. Virtually all image processing algorithms you will find in any computer graphics text will assume pixel data with linearly encoded light intensities. Are you catching this? Which means that feeding these algorithms with sRGB encoded data will render the results subtly, or in some cases quite obviously, wrong. This includes resizing, blurring, compositing, interpolating between pixel values, anti-aliasing, and so on, just to name a few of the comments. So yeah, this is saying what I'm saying. Yeah. I'm trying to help you understand this because I think a lot of people read this kind of stuff and get the idea wrong. sRGB is the format you want to use to send data to the screen and to send data to a PNG file or a JPEG file, but it's not the space you want to use for doing math that combines colors together. And that's what he was saying too. The problem is you need linear space colors for color algorithms, but you need sRGB colors to encode them efficiently and to display them correctly. So the point is you store stuff in sRGB, you convert to linear to do color algorithms, and you convert back to sRGB for the final display, which is what we're doing here. Anyway, let's move on. I'm trying to just make this look good, so let me just play with it a bit until it does. I'm sorry if I got a little short there. It's just, this is a particular topic where I feel like everyone explains it really poorly, and it leads to a lot of people being confused. Because they start with the whole thing about the eyes, it makes it sound like you want to think about people's eyes when you're programming it, but you actually don't. All you need to think about is the difference between the inputs and outputs of different color types. Okay, so let me play with this one more time. Does that look good? Blah, blah, blah. I guess one thing I don't know is I don't know what it looks like when it's moving around and changing, which is what I really need to get to. So let's say we've got the building blocks. We're not quite sure how to put them together yet, but we want to start applying visual effects that change over time. So let's do something very basic first. I want to get an approximation from my audio. Yeah. Yep. Here we go. Let's forget about this part for now. And instead, let's try to figure out, can I make a buffer I'm going to try to make a buffer of floats that has one value per frame that this thing will be running. So we're going to assume 60 frames per second and 44.1K hertz. And we want to figure out how many frames there are. The frame count is whatever you get when you take the sample count multiplied by 60 divided by 44100, except we want to take a ceiling rather than a floor. So ceil integer, do I have, I've got to have like int div, come on, I've got to have one. Ceil div, I don't have one. Crazy. Do I have like max and min? Yeah. I just don't have this one yet. Okay. Ceil int div numerator denominator is numerator plus denominator minus 1 divided by denominator. Ceil int div that gives me my frame count, and then approx volume across each of those is going to be like this. Frame count. This one here is going to be approximate volume on each frame. It's not really approximating the volume, though. That's a little bit wrong. I kind of want to just, like, activity level. I want to just, like, measure perceptually the activity level of a channel on each frame. Okay. Let's do a little drawing here. So, drawing time. What I'm gonna have is we have, I don't want to have to scooch over, so. We have like frames, right? What are we doing here? Are we, gonna have to restart Milton, I think. Or is this thing disconnected? What happened here? I seem to have lost. I seem to have lost my tablet's drawing function. Okay, tab, pen is back. Bring back Milton, tab. There we go. So we have frames. They're going at a certain rate. We have this signal, which is like an audio signal, right? Now it's going a lot faster. If this is going at 60 times per second, and this is going at 44,100 times per second, then what I want to do is first of all say like, okay, first of all, we want to talk about how do we even approximate the activity level. And basically what's important is in a signal, right, of audio, if something is high or low doesn't matter. What matters is how much it's wiggling, right? So if it's like a constant 20, that's actually silence. If it's changing, that matters. So we want to look at the relative difference, like the relative variance in the strength of the signal over windows, and then we want to apply that here. So like in this frame here, we could say like, what's the relative variance here? But that leaves there's a couple different ways we could think about that. There's still a question of like, how do I check the variance right here at the edge? Well, I still have to look at the like space around that a little bit. Or I could just say this is an approximation system. I want to make it easy. So grab all the samples relevant to this one, like that are in this one frame, and get variance there. The issue with that is that if it's really loud at the end and quiet here, I might get a low variance even though I want to render that something happened, because you're not going to really be able to tell the difference between a little bit of volume and a lot of volume at the same time. All right, I got some tips from chat. I'm going to follow down what they said because otherwise I'm just going to make something up that's probably not going to be as good. Andrew Harder, are you taking the RMS of band passed frame? I'm not sure what you mean by that. That's a little bit too much jargon. I don't know what RMS means, and I don't know exactly what you mean by band passed frame. You looking for derivative E? How is that E with a? Let me see. Are you just trying to say you're looking for a derivative? Is the extra E with the accent intentional? Does that mean something more particular? Yeah, I'm looking for derivative, pretty much. Gotcha. Root mean square. Yeah. So if I look at variance in terms of a statistical perspective, I could just look at root mean square, which is kind of where I was thinking of going. Like, what's the what's the statistical variance of the signal. Yeah, okay, that's kind of where I think I wanted to go with that. So let's try that. Let's just to make sure I don't do anything too stupid, let's Google that phrase. Root mean square. Oh, that's what RMS means. Yeah, I'm not great at jargon, but this is basically what I was thinking of, right? So we take the square root of the average of the squares of all the values. But I actually want to take the squares from the mean, right? So I want to take the regular mean and treat that as the center. And then I want to take the squares of the differences from that. Yeah. I think I know what I want to do. A lot of good ideas. Thanks for the help. So for each frame, what we're going to do right, so if I do standard deviation, that would just be don't take the square root at the end, right? Right. The standard deviation is just the root mean squared. Like, it would just be this without the square root, right? Pretty sure. Alrighty, let's just try this. So I want to look at each frame. Yeah, the difference is just a matter of a square root at the end, I think, right? So it really doesn't, one way or another, the majority of what I need to compute here is the same. So now I want to pick a range of the mixed samples. So first sample is going to be mixed plus I times, let's see, how many, I need like a rate here. Sample per frame is just going to be 44100 divided by 60. Does that divide cleanly? Yeah. Sample per frame. One pass last sample will just be, well, first sample I. Let's do this carefully. I times sample per frame U30 OPL sample I raw is first sample I plus another sample per frame. OPL sample I equals clamp top. This way we don't ask for too many samples. Sample count. Right, I think I do want the standard deviation. Like, that's what I was trying to say a second ago. I think I do want to subtract out the means, because if I just do root mean squared, well, I mean, it would be easier to compute root mean squared without, I don't want to put this, whether or not I treat 0 as the center is the only question there. But like, if I go into Audacity, or if I print out a wave file where all of the sample values are, you know, at 0.5, it would still sound silent, right? Like, it doesn't sound like something. So it shouldn't count as sound if I have a large constant signal. but it should count as sound if I have a lot of variance around the mean of the signal for a frame, right? So first, let's get a mean by going across all of our samples and adding them up. And then at the end, we'll divide by sample per frame, right? And then what we want is the variance, which I'll accumulate like this. So we iterate this again. And what we're doing is we're taking F32S to extract the sample, and we're doing F32D, for instance, would be, okay, yeah, so D is going to be sample minus the mean. And notice I'm just going to treat it like it's a bunch of zeros, so I might be clamping out a bunch of like steps here on the last frame. The last frame's not that important anyways, but on that last frame, it's going to basically treat it like there were a bunch of zeros there because I'm keeping the sample count the same even if my window is smaller. So it's like I have a bunch of zeros at the end of the last frame, which is good enough for me. It might technically like modify, like it'll be fine. Whoop, I already did that, so D squared, so we square those, and then var divided by equals. Why don't we... sample per frame. Okay. So I'm just looking over literally the samples that go with a single frame. Nothing particularly more clever than that. I could like extend the window just a little bit on either side, which would probably be better, but I'm not doing that yet. If I did want to do that, I would just have to modify how I grab these firsts and lasts and modify the frame mean norm a little bit. But I might also then have to think about some other things. I think I'll go with this. So this gives me the 2 passes over the block of samples, gives me the variance to that particular frame. And then I'm just going to store that out as my frame activity level. All right. So questions are like, do I want to square root this or not? I don't know yet. Why don't we just take a look at how that at how that becomes a new signal for us first. And why don't I go ahead and stick that into our processed track here. That's a mistake. Okay. I speakers. Why don't we call this speaker I? We'll grab a speaker pointer. Since this is a higher level loop, I don't want to use like short variable names for it anymore, because I would just get lost like in the context too easily. Okay, so for each speaker, there's a processed track, speaker I. Let's grab that. And fill it out. So the processed track frame count, we got that, and the processed track frame activity level, we've got that, right? Yeah, so I've got a frame activity level and a frame count. I stick it into my processed track. And now I can come down here and grab the processed track from this speaker. And then I can say, give me the activity level for this speaker. Frame counter. Yeah, that's a good point. I might want to switch from... Yeah, it's also interesting. Should I be even doing the samples, or should I just be... I should probably be doing the log first, right? In order to take samples into decibels. But I don't know. This stuff is a little, you know... This stuff is a little bit like hard to piece together. I don't quite have the full type system of signal processing implemented in my head properly yet. A decibel isn't really a thing that makes sense to say about a single sample. It only makes sense across a group of samples. But I still feel like you would want to do the log 10 first. Maybe? I don't know. It does seem like the log should probably be in there somewhere. Because we don't want like really small wiggles to show up as wiggles. We kind of want like when someone's talking, yeah, we'll figure it out. We'll figure it out. So if the frame counter, which measures, you know, it's up here measuring how many frames we are into the animation, is less than the frame count, then we can get the activity level as something from this track by putting the frame counter in here. So now I've got an activity level. Now I have an activity level, and I want to try to set this based on the activity level. So let's say that we're just going to make an L value here, which is going to be 0. And then If activity level becomes greater than 0.1, or why don't we do this? L is going to be the unlerp of 0.1 as the minimum of the activity level up to, let's say if you reach an activity level of 0.6, I might also need to know like the maximum, like it's possible that the entire signal doesn't go ever above like 0.8, right? In which case the maximum variance is lower than a signal that was encoded with, that maxed out at 1. On the other hand, that's going to show up in how loud these things are. So yeah, maybe I don't want to do that. And then I want to clamp L raw so that it doesn't go between more than that. And then here I can lerp so yeah, let's do that times, at the low end, let's make it as small as 60% of its normal size, L, and then 100% of its normal size. And then when you're talking, when you're not talking, you have a desaturated avatar, and when you're talking, you get fully saturated avatar. And then when you're not talking, you get fully desaturated on the edge, and when you are talking, you kind of fall off a little bit less. I can't really see them changing at all. So we want to go and check, like, this one should be talking. And I can't hear them, which is probably going to be a huge problem. It'd be much better if I could play this and hear it at the same time. So we might want to try to solve that issue. Let me just double check a couple things. My frame counter is actually counting, right? Yeah. So let's take a look at what those activity levels are turning out. They might just be turning out all to be way too close to 0 or something. Because that just looks like an activity level of 0, right? Yeah. Okay, what do we have here? Frame count. So it's got about 4,000 frames. Let's take a look at each step here. First sample I should be 0. One past last sample I. 735 makes sense. So we grab those samples. First sample, okay, so let's find out what the mean turns out to be. Should be close to 0 if like it's a reasonably encoded signal. Yeah, so pretty close to 0. And then the variance is where, let's find out, D makes sense. We square that and add it into the var. So after we've done that a bunch of times, what does the variance look like? It's pretty low. So there's like some movement there. Let's take a look at the whole thing. Yeah, so in the first like 60 frames, we get the first full second, and I'm definitely talking in the audio clip there, but the variance is not getting very high. It's staying pretty close to 0. So I could try square rooting it. That would make some of these things, like this would become a 0.1-ish, but that's still pretty small. So probably I need a log. In here somewhere. I think I also just need a smaller window. And then I need to like take a max. So like what I just did was I took 700 samples and I said, what's the variance across this entire thing? But the variance across that entire thing isn't really how perceived volume is going to work necessarily. It's going to be like, you know what I'm saying? Like what I should really probably do is take like 50 samples at a time. Because if there's a sharp change inside of 50 samples, that's going to lead to a higher variance. And then I can max those. Whereas if I have a signal which is got a couple of peaks in it, but then mostly is hanging out quiet, like I'm talking and, you know, it's going up and down in small ways and a few big peaks really define the shape of the sound, I'm going to still get a low variance overall, right? So yeah, let's do a couple of things here, a couple steps at a time. One, activity level. I think I want to try mole from decibel. Do I not have the other way around? Decibel. Yeah, I would need to invert this. So let's see here. Here, R equals pow F32 10 dB over 10. So if I solve for dB, first of all, 10 to the power of, so this is log of R is equal to dB divided by 10. dB is equal to 10 times log R, right? So let's look at the first things first. Let's look at the mean, or the variance of the standard deviation, I suppose. I can't remember which one is standard deviation, which one is variance, but let's look at the variance / standard deviation-ish thing that you get from converting the difference of a sample from the mean value from linear to decibel, and then applying the variance on the decibel space. So this is like the variance in decibels. Now, I'll start from right here. -30. Oh, that's not going to be good. No, that's not going to be good because like -30 should be considered low. Sample minus mean is very small. So yeah, because when I do this, 0 doesn't mean quiet. 0 is like the loudest possible thing. Yeah, no, this isn't what I want. I mean, our variance is going to be like gigantic now. Okay. Yeah, that's the wrong way around. So let's take that standard deviation or variance. Let's just try decibel from linear at the very end. Let's try that way. So we'll see what that looks like. RDB. It's still, well, yeah, that's pretty usable, right? Because like that went from -60, which is very quiet, to -18, -20. These are like sounds you can hear. -30 is pretty quiet, but -20, yeah, that I know how to interpret how loud that is. Each frame here. Yeah, so when it gets to like -30, it's pretty quiet. Here you can hear something. I feel like this could be usable. I don't know if it actually correlates well with the real input sound, but that seems pretty good. Let's also do the thing where we shrink the window. So So let me see what I get if I do something like that. First sample J. Okay. Max var db. Okay, that's surprising. Why is it suddenly... Maybe with smaller... Oh, wait, I'm using the wrong mean norm. I need the window mean norm now. Frame activity level. Well, max var db. -12, -80, -20, -7, 19. Man, some frames it just turns out real small. What is up with that? The var is turning out to be 0. First sample, last sample. How is it turning out to be 0? These should all... The mean is 0. What on earth is happening here? Okay. First sample. One pass last sample. Mean. So our mean should be like that, and then D, the var window size. So yeah, that ends up real small. Var db. It's real small. Okay, so that's the first 50 samples. It thinks are real quiet. But does it? Why does it keep thinking that for the whole time? 12. Maybe the window size is just too small. Let's do a bigger window. No, that's still not helping. What did I want to see? I wanted to see, yeah, just give me this. At the end of everything, what's the frame activity level like in the first 500 samples? Whoa, okay, that's definitely not it, right? There's 1, 2, 3, 4, 5, 6 frames, and then silence? No way. So that's just some bug in this. There's just some bug in this. Frame count for each frame. J is 0. First. Oh, I see it. I see the issue. This is wrong. Oops, not that. This is wrong. So J gives me a sample index. So I don't want to multiply by sample per frame again. Up here, I is a frame number, so sample per frame makes sense. Here, J is a sample number, so it's just, yeah, yep, that's the bug. It's just jumping to the end of the signal way too fast. And now, what does the frame activity level of this array look like for the first 500 values? Very quiet for 2 frames, barely audible, talking. Yeah, that's good. It gets a little quiet, talking. All right, now we know that after a few seconds, it was like 15 seconds, I think, was when it changed over. Let me pull open the test track, actually, so we can see exactly where it is, since we can't hear it yet. Yeah, here it is. So it's at somewhere between 12 and 13 seconds. So let's look at 13 seconds at 13 times 60. Yeah, now it's super quiet. Okay, this looks like it might be usable. So I'm getting a decibel measurement, I think, roughly, of how loud the signal is for a given frame. So yeah, at 11 seconds, there's talking, and by the end of 11 seconds, it goes quiet. Yep. Yep. That seems right. Right? Like, here, if we just look at this 60 frames at a time, these are each represent the volume at a certain frame, and by the end there, it's super quiet, but right about here, you can see where it's falling off. I think this is it. I think we got it. So now what I need is I need to change the range. I need to interpret the activity level as a decibel. I'm going to take a little note about the units of the activity level. Activity level is measured in decibels. Activity level dB. Now, that means that an upper range, like, okay, if it gets anywhere above, let's say like -12, then it's full activity. And if it's anywhere below -40, it's no activity. That might be a little bit too small here. I might want more like 30 or 33 or 36, but let's start with that as a idea. He's talking. He's talking. He's talking. Okay, so we probably want to smooth it out a lot harder. He's talking. He's talking. Okay, this is good. This is getting there. I really need to be able to hear it at the same time as it's going. So let me see if there's any good way to do that. I can't very easily do that because I don't have any way to play sound from my program yet, but I do have this plate like temp wave thing. Play sound A. The question is, if I do that, is that a blocking call? Say like right here on the beginning of the first frame, I just drop in a little, full path. I could render this out real quick. Okay, I'm rendering out the whole mixed track. Open file location. Let's take this over to the podcast test folder and give me the full path there. Test combined.wav. Does this work? All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get two tracks of two people talking to each other, but there's only the two of us in the room, so it's got to be you and me.
Yeah, hi, normal Alan. This is gonna.
Okay. So we're getting there, but I can't actually do it that way because, as you saw, it does block. So, I mean, there's only like one real obvious way. I could go and see if there's a way to play sound non-blocking. All right, let's try that. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get two tracks of two people talking to each other, but there's only the two of us in the room, so it's got to be you and me.
Yeah, hi, normal Alan. This is gonna be super awkward because I'm literally just a person.
Okay, this will work. All right, so I have a bunch of ideas now. We're kind of at the spot where we got to do things like this. So aggressively smooth out activity levels. Um, tune changes in size with smooth versus high frequency activity levels. Tune changes in avatar appearance with smooth versus high frequency activity levels. Let's see, other ideas. I'm going to make this list of ideas, take a lunch break, and then we'll get back and start working on more stuff. So I want to just generate this list of ideas and call it good for now. I want some frequency analysis features, maybe. Wiggle the outer edge of the circle more. Push towards center during active moments. Determine active avatar silent mix a master track and do analysis. Timeline effects. More interesting layout with 3+ speakers. Okay, I think this is enough ideas. Yeah, let's take a break. I'm gonna go get some lunch, and when I get back, I'm gonna start trying to make this good enough that I could ship it. That way tomorrow I have something that's good enough to ship and we can just iterate. I don't want to leave this hanging, so that on Monday when I actually want to use this, I am guaranteed to have something. So I'm going to go for good enough that it could go out the door for the rest of today, and that way all of tomorrow can just be gravy. All right, I'm here talking to Anti-Alan today. Cool. All right. Yeah, I'll see you guys again in a little bit. Bye-bye.